Welcome. So there were some questions on the last couple of discussion boards. So I wanted to actually create a quick video going over discussion board, each of them. So let's talk about discussion board 18. That was the Elgamal digital signature. So the first question was Samantha has the signature scheme where her P is 6961 and a primitive root is G437. First question was if her private key was little a 6104, what's her public key? As remember, her public key is going to be the big A, was just G, the A mod P, which is going to be 437 to the 6104 mod 6961, or when you go through this, all the calculations. Again, I wrote a fast exponentiation program. Some of you I know have found some packages. I again recommend if you're going to use a package, make sure you go back and look at the code as to what is really happening underneath the hood. So you're not just trusting that someone else magically made a package that works. Is this actually the exponentiation? And what is the order in which it? I mean, algorithmic efficiency is actually a key thing that we do have to talk about. The second question was if Samantha signs the document 5584 with random key 4451. Again, S1 is just G to the K, which is when you take the 437 to K, it's going to give you 3534. S2, remember, is going to be mod P minus 1, which when you do all that again, so a couple things. D, this is already known. So this is known, A is known, S is known. The question is, how did I find this? Well, because I know K, I can use the extended Euclidean algorithm. Again, I wrote a program because I'm not going to do extended Euclidean algorithm on numbers that are this large. And it just makes the process a little bit easier. But you can write it very simply, go back and think about how it works. Your textbook even walks you through the general process. So you can do this real quickly, and then you have K inverse. And then all we literally have to do is do all the arithmetic and then take that mod 631, which is going to give us 4250, sorry, 4240. So the signature are those two values right there. So this one should have felt very much as computational. Go ahead and walk through it, kind of get an idea of what's going on, get familiar. If you made arithmetic mistakes, okay, again, they should make sense. I mean, you can go through and stop and think, At this point, I would recommend that almost all of you utilize your coding skills. Like this is why we actually code, is to do computing. But because that's why it's called computing science, by the way, computer science. I don't want you just to copy in something else. I mean, too many people do that and they don't understand what they're doing. They're just using a formula without understanding what it is. Please try to understand it. The way you're going to be effective in these fields is to actually understand those and not just simply copy and paste. As AI becomes a bigger and bigger thing, if all you are is someone who copies something off the internet and don't actually understand how to build something new and creative, your value is going to go down significantly. I'm just going to be honest about that. All right, so let's move on to the last question, which is Samantha used the same K for two different documents, D1 and D2. The first question was explain how Eve could tell at a glance that she made this mistake. Well, the thing is, remember S1 for both documents would be G to the K because they have the same K value. And all Eve has to do is look at the signature, the first component of those signatures, their first element in the tuple or list or whatever you want to call that, and notice that they are the same, therefore K is the same. This gets where the second one is interesting. The truth is, Eve can do it. She can recover the actual secret A, not just K. She can get K and A if you do this. So it doesn't just compromise the signature, it compromises the entire system. So if Samantha does this, this is really bad. And the reason is, if you look at this, these are two equations that we are going to come up with. These are the two, this is S2 and S2 prime. They are going to, now the problem is the things that are known, let me highlight every single thing that is actually known in here. So these are the things that Eve is public knowledge to. She has both of these. She has the S1s, which I just put this one down here below should technically have a prime on it, but it doesn't really matter because remember, they are the same value. So we can just get rid of that. All right, so those are known. What else is known? Well, the Ds are both known hypothetically. I mean, obviously, they could be encrypted, which would actually make it a little bit more secure, but let's suppose they're not. The Ds are openly signed. If you were to do this and make this a mistake with an openly signed document, notice in both cases, A and K inverse are the two things I do not know. If you have two unknowns and two equations, you can solve for the unknown value. Now, the way we would solve in this particular situation is you just subtract them. So take the top equation and subtract the lower equation, and we get this minus this. But again, if you multiply out our K inverses, I get this line right here. Rearrange them, and notice we have the D K inverse minus D prime K inverse minus, now this is the key thing. I have A S1 K inverse plus A S1 K inverse. Those two are going to cancel out, and then I can factor out these. Now, if I do that, I have this. Now notice, again, what is known and what is unknown. Eve has access to both these numbers independently, so she can quickly calculate what is S2 minus S2 prime. She can similarly calculate out this. Now, here's the point. All of this would have to be done not actually in a computer, but symbolically done to get this formula. And once you have this formula, you realize, hey, essentially, I'm giving Eve something that looks like this. I'm giving her something that looks like, given a number n is congruent to another number, let's say j times k inverse mod p minus 1. So and that's easy, if j and k are known, we know how to do this using the extended Euclidean algorithm. This is just a really straightforward process. We've done this a whole bunch of times because we do this to solve for the inverses. And in fact, the inverse of k would be, k inverse would be k. And thus, I have just found myself k. Once I have k, I can come back up to either one of these first two equations, just for sake of, I'll use this equation. And now if I know this number, all I have to do is work my way back through. I can then work my way back and easily identify what is A, again, using extended Euclidean algorithm and so forth. So this is highly vulnerable. And this is the problem with this is you constantly have to come up with a new way to sign things. Each signature must be unique. And that's kind of the key thing. All right. Hope that helps explain the process a little bit for you. And let me know if you got any other more questions.